All right. So for number 16, like I kind of warned you yesterday, each rule taken individually seems pretty easy. When they all get thrown together, which is what we're going to do a little bit here in the last two pages, this becomes some of the stuff that people have a harder time with overall, even though it looks like a pretty simple little problem. So this is a nice one to review with. So quick little review before we do this actual problem. One of our rules from yesterday is the idea that, let's say I gave you x squared y to the fourth, and then I cube all of that. So the rule is if I have an exponent, so I have these two terms, and this exponent is being raised to its own exponent, that means we actually multiply those together. So we would have done 2 times 3, going to give you that 6. And then our y, the 4 being raised to the power of 3, we multiply those together. They're going to give us a 12. All right. If I throw a number in front of this, just be careful, because if I put a 2 right here and I cube that, we still are going to do that normally. So we still need to do 2 cubed. That's 2 times 2 times 2. And that should give us an 8. All right. So that's the rule that we're going to use here, but the negative exponents tend to cause some issues. All right. So let's first do the rule with this problem. So the 6 currently has a power of 1. And we know that if I have a power raised to another power, we multiply those together. So the 1 and the negative 2 make a power of negative 2. So that would get written as 6 to the negative 2. All right. And then if we do our x's, the x has a power of a negative 6. That's being raised to a negative 2. And then our rule says we multiply those. So that's going to be a power of 12. The negative 7 times a negative 2 gives us a 14. And then 0 times a negative 2 still gives us that power of 0. All right. But what we also talked about yesterday is we don't want negative exponents. So this little negative exponent here is a problem. We don't want that. Quick little review on that. If I gave you like something like this, x to the negative third, and then let's do a y to the fourth. Whenever you have a negative exponent, what that's really kind of saying is it's in the wrong spot in your fraction. So if it's currently in your numerator, we can turn that exponent into a positive exponent if we move it to our denominator. All right. So if I did that with this problem, now that x cubed is positive. So it's the same idea right here. Right now, since I don't have this written as a fraction, what that would mean is all of this is being divided by a 1. We can always divide anything by a 1. So if I now want to make this a positive exponent, oops, there, that's 6 to the negative 2. And let me show on the calculator again, just so we kind of understand what this means. If I throw 6 to a negative 2 on the calculator yesterday, maybe even today still, some people may think this is a negative 36. All right. But if we throw this into the calculator, it gives us this weird 0.0277. It's actually a really, really small number. All right. So 6 to the negative 2, which is what we currently have right here, is a really tiny number. And the reason it is a tiny number is because this exponent is telling us we don't want this in our numerator. So we want to take this, move it into our denominator. So in that next step, what I'm going to do is I'm going to make this fraction bar. I'm going to put the 6 into my denominator now, but now that exponent magically becomes a positive 2. The x to the 12th is fine. The y to the 14th is fine. One of our rules from yesterday, if you were not here, anybody remember what anything to the 0 power was from yesterday, Kat? That's a 1. So if you don't believe that, if I were to give you 10 to the power of 0, that is a 1. All right. If we did yesterday, we did a variable to the power of 0, 1, because it doesn't matter what it is, as long as it's not a 0. Anything to the power of 0 is a 1. So that just cancels. You don't have to put a little times 1 at the end. It's unnecessary because it would just remain the same. But what we do get is that 6 squared becomes a 36. So what we really have is a 1 over 36. So if I now go to my calculator, watch what happens when I plug in a 1 divided by 36. Notice how it's going to give us that really small little number that the 6 to the negative 2 also gave us. Okay. So a lot of little things there to be aware of, to be careful, but that ends up being our final answer. All right. Okay, the next one. Let me give you one of these with numbers here. So all this is saying is I have a fraction, and that whole fraction is raised to a power. So let me say I come over here, and I'm going to give you 2/7, and I want you to square that. As long as the parentheses are around everything, then everything inside of the parentheses gets raised to the power of 2. So that simply means I'm going to do 2 squared in the numerator, and I'm going to do 7 squared in my denominator. Just square both of them. So we would all know these, I would hope. 2 squared is 4. 7 squared is 49. That would be our answer. So that's what this is simply saying. Square everything in the numerator, everything in your denominator. So real quick, with that understanding, try 17. So go ahead and square 17, or whatever it was. Yeah, square 17. What do you got, Hannah? Good. So 3 squared is 9. 5 squared is 25. That is our answer. Okay. If you want to actually write 3 squared over 5 squared, that in between step, that's fine. But we do ultimately want to simplify it as much as we can, which would be 9 over 25. All right. All right. 18. So if we did now 18, this will be another rule for those who weren't here yesterday. First and foremost, if I asked you what is 2 squared, we just did that earlier. 2 squared is a 4. All right. So that's easy. Then, if you weren't here, this is a second rule or another rule. So if I have a to the 5th raised to the power of 2, that should give us, anybody here yesterday remember what we do there? What is a to the 5th squared, Kat? To the what? Not, we don't add exponents for this. If I had this, a to the 5th times a squared, then we add the exponents. All right, Marian, what do you think? Good. When we have an exponent raised to another exponent, you multiply those. So that should be an a to the 10th. All right, 5 times 2 is going to give us a 10. All right, same thing in our denominator then. This is b to the 7th, and then that's raised to the power of 2. So just like Amarian just said, we're going to multiply those. 7 times 2 should be a 14. All right, so power raised to a power, you actually multiply them. Okay? All right. This guy. 2 different routes we could take to solve this. We're going to do the route that we kind of have been doing 2 or 3 times now today. One of them is to just take each term. So take this 3 and you're going to cube it. So I'm going to write that as 3 cubed. Then take the a. So this is a to the negative 4th. That's going to get cubed. But again, this is now one of our rules. A power raised to a power, we multiply. So that's going to be a to the negative 12th. And then in our denominator, I have this b to the 7th raised to the power of 3. So another power getting raised to another power. So Maria, that would be b to the what? 21. Good. So b to the 21st. Okay, so that's our first step. We want to simplify as much as we can. So when I now ask, all right, what is 3 cubed? All right, don't tell me it's a 9. That means I have 3 times 3 times 3. Good. So 27. Then we come across this. So we just did one of these. If I have a negative exponent, it is basically telling us it's in the wrong location in our fraction. So if it's currently in the numerator, which it is, in order for us to turn that into a positive exponent, we're going to put the a into the denominator, and then that makes the exponent a positive 12. All right. So what that would then mean when we come across the b in our denominator, does that b need to get moved? No, because it's a positive 21. That means it's in the right spot. We just leave it in the denominator as a 21st power. All right, and then that's our answer. Okay. Now, just so you know, and I do want you to do this on the bottom, rewrite this problem underneath it because there's options for all of these. So I want you to kind of see what another option is to solve this. This one actually maybe is a little bit more in line with what we you would have been talking about for a number of years, and the idea of order of operations. In order of operations, doesn't order of operations tell you to do parentheses first? So what we really could do is simplify inside of the parentheses. There's not much we can do with the 3, but couldn't we take this guy right away since it has a negative exponent? We could actually make that a positive 4 right away if we take it from the numerator and put it into our denominator. The b to the 7th, he's fine. He's not causing any issues. He's just hanging out. He's already positive. So that's now our inside completely simplified. We just move the negative exponent down. And then now if we cube everything, 3 cubed still gives us 27, just like we got on the other way. A to the 4th cubed, multiply those to get a 12. And then b to the 7th cubed, multiply those exponents to get a 21, and we get the same answer either way. So we could also approach it that way. A lot of these have some different options, okay? All right, before we go to the next page, see what you think about 17. So solve that guy. All right. We have this a to the negative 2. So we really have two options. Now you can make that positive right away, putting into your denominator, or we could go ahead and just do that negative 2 times the negative 6. All right, if we do that, that should give us a to the what? 12. And that's positive right away. Okay. If we then go to our b's, this b to the negative 5, right away, just raise it to that power of a negative 6. That looks bad. All right. Wouldn't that then give us a b to the positive 30th right away? And then in our denominator, the negative 11 and the negative 6 should be positive 66. Don't these all now have positive exponents? So we don't have to do any more work. All right, that's your final answer. Okay. All right, I'll leave that so people are still looking there. All right, go to the next page. I think there's one more thing, right? 17. No, now these are all. Okay, so if you weren't here yesterday, we're going to start really, really slow. Hit on these rules, and then we'll slowly add layers to this. So our very first rule from yesterday is if we are multiplying like terms. So if you look at number 1, we are multiplying 2 x's. When we do that, that's when we add our exponent. So it's just an x to the 8th times an x cubed. That's x to the 11th. So when we multiply like terms, you add their exponents. Second rule that we did yesterday is if we here have an exponent raised to another exponent, we just did some of these, that is when you multiply. So we actually multiply 8 times 3 should give you a 24. So those are 2. We started yesterday with some pretty simple little guys like that, and it started with those 2 rules. We've talked about this rule a little bit. We don't like negative exponents. So what we talked about yesterday is the idea, if I just gave you the number 6, couldn't we say that has a 1 underneath it? We could always put a 1 underneath anything and turn it into a fraction. So it's the same with one of these. Put a 1 underneath this, and we've just turned this into a fraction. And then that negative exponent is basically saying we're in the wrong location on that fraction. So if it's currently in the numerator, the negative is indicating that it belongs in your denominator. So we're going to put that into our denominator, becomes a positive exponent. And then the only thing left over in the numerator would be a 1. 4, we've already talked about. We said anything 1 to the 0 power is a what? 1. So x to the 0 is a simple 1. So those are 4 of the rules that we talked about yesterday. As you see those, and there's one more. I think it's number 5. If you go to number 5, this is the final rule, and then all the other rules are just layers of this. When we are dividing like terms, first time I think we've done this one today. What do we do when we divide like terms? What do we do with our exponents? Subtract. So we would write this as, and when we subtract, it's always the exponent in the numerator minus the exponent in your denominator. So that should leave us with x to the 5th power. All right. So now number 6 is the first one that combines a couple of rules together. So if we go ahead and do that same rule we just did, where I'm dividing like terms, and then Riley said we subtract these. So we're going to do 3. If I get my marker to work, 3. All right, try that, because that guy died. Minus 8. All right, so the exponent in the numerator minus the exponent in your denominator, and that gives us an x to a negative 5. So notice the similarities in those two. It's the exponent in the numerator minus the exponent in your denominator. Number 5, we're done. We were done with this one because it had a positive exponent. There's nothing else we can do with it. What ended up happening here, we ended up with a negative exponent, so we're not done. We always want to end up with a positive exponent. So now this is like number 4. We don't want to leave this where it currently is at, which would technically be in the numerator. So to make this a positive exponent, we are going to slot that into the denominator of that fraction. And then the only thing left over on top would be a 1. All right. All right. So with that, 7 combines some rules. So see what you think for 7. Now we've got getting kind of into these that combine multiple rules. See what you think for 7. Okay, anybody got an initial thoughts on what you would do first? Diana, what do you got? Good. So one option that we definitely have, I think this is probably what most of us would do, is to do the top first. So if I ask you to simplify the numerator, what do you think that is, Diana? You say x to the power of 6? Okay, good. And that's correct. Because when I multiply like terms, we add the exponents. So 8 plus a negative 2 is a positive 6. Then the denominator can't really do anything with that. So we now have 6 x's on top. We have 3 x's in our denominator. You know what to do next, Diana? Good. So that should give us x to the what? Good. I'm going to show it just since some people are just seeing this for the first time today. We subtract those exponents so that ultimately our answer is x cubed. And if you go right to that, you don't necessarily need to show that step, but x cubed is our answer. Okay. All right, 8. If you understood that, we should now be able to do number 8. So get your answer to 8. All right, Sage, what do we get in the numerator? Good. So our numerator becomes an x to the 15th. Haley, what do we get in our denominator? Good. X to the 9th. 3 plus 6 is going to be a 9. And then when we now divide these, Nadia, that should give us x to the what? Good. X to the 6, because we do 15 minus 9. All right. And then that's it. All right. Good with that. Questions? Yeah. You couldn't. So what was your? So a lot of these have some different routes here. So let me rewrite it. No, that's good. It's good to see it. All right, what'd you do first? Okay. So what Hannah said, she actually did this first. So she did x to the eighth divided by x to the 3, and that would have been x to the what? Good. And then, did you do these two then next? Okay. Then she did these guys next. So x to the 7th divided by x to the 6th would have been x to the what? 1. And then now when we multiply like terms, we add those exponents, right? So that would still give us that x to the 6th. Yeah, all of these have probably at least 2 ways, sometimes 3 or 4 different ways. Yeah, so that's good. All right. Number 9. Do that one. See what we get. Hopefully a nice one. Okay, let's see what we got here. Sarah. And all we're doing is multiplying the like parts. All right, so Sarah, what is a negative 4 multiplied by the other number, the positive 7? Good. So negative 4 times a positive 7 should give us a negative 28. All right, and then from there, who was here? I'm trying to remember who was here, who was not here yesterday. Catherine, you were here yesterday. What do you think, Catherine? X to the 12th times x to the negative 5 would be x to the good. 12 plus a negative 5 is a positive 7. So again, when we multiply like terms, you're adding their exponents. All right, and then last but not least, if I did y to the 8th, y to the 10th, Brandon, when we multiply these guys together, y to the 8th, y to the 10th would be y to the what? Good. Y to the 18th. And then that's it. All right. All the exponents are positive. Everything is all sets. All right, 10. Again, multiple rules here. So what you're going to want to do, so I'm going to give you a minute, see if we can get all the way through this. If you get this, pretty good. We want to simplify this one first. We do exponents first. So go ahead and figure out what that one's going to reduce down to. Then we want to identify what this one will reduce down to. And then notice how they're being multiplied together. So once we've done each quantity, we then want to multiply those results. So see if you can get this. If you get this, pretty darn good. Pretty darn good at this point. It's 2 days in. as well. No, those are exponents, so that only is for your exponents to be that. Numbers behave normally. So you're just using -5 squared. You're close. Here's the answer as people are finishing. You can see if you got it right. So if you got that, good on you. Pretty good. If you didn't get it, we'll go through it here in a second. You got it, Destiny? Now all your variables, you're just really, really close. Why do you agree? So -5 squared, then -5. All right. So first things first, let's be clear about one thing, and I'll show it on the calculator. If I go to my calculator, there is a big difference between -5 squared without parentheses, which is going to give you a -25, and a -5 within parentheses that gets squared, right? Two completely different answers. So we want to make sure we understand which one we are dealing with. So if I look at that problem that we have right here, is this negative inside of the parentheses that is getting squared? Is the negative part of the parentheses that's getting squared? Yeah. So if we look at my calculator right now, which one are we dealing with? The -25 answer or the +25 answer? The +25 is that -5 getting squared. So when we go to simplify this one, the -5 squared should have given you a +25. All right. Now, the good thing is, all the ones that I looked at, everybody had these variables correct. So everybody knew that 6 times the 2 is going to give you that 12. We're going to do a 3 times a 2 is going to give you a 6. Everybody had that down good. All right. Then the next one, I saw a few 150s out there. All right. If you did a 150, what you told me is that 2 cubed, right? Because we're taking the 2 and we're cubing it. You're telling me that 2 cubed is a 6. But isn't 2 cubed 2 times 2 times 2? What's the first 2 times 2 going to give you? 4. And then what's 4 times that last 2? An 8. So 2 cubed should have ended up being an 8. But then the variables most people are pretty good with. This has an x to the first power right here. 1 times 3 is 3. And then the 9 times 3 is 27. So that's what each one of those individually simplify to be. Then we multiply. So if I did the 8 times the 25, that's where the 200 comes from. If we then do our x's, x to the 12th times an x cubed, that's why we get an x to the 15th. And then the y to the 6th times the y to the 27th, when we add those, that's why we get the y to the 33rd. Okay? If you got that, that's really good. All right? For the first time, really trying one that's a little bit harder. All right, squared away on that now. We can do that in the future, hopefully. Maria, good. All right. All right, number 11. So let's now go to number 11. This should be a nice one. The numbers behave normally, so there's no weird rules with regular old numbers. If I ask you what 33 divided by 11 is, that is still, as it always has been, 3. All right, so 11 goes into 33 nicely 3 times. But then we get into our exponents, and these are the ones that now have the kind of different rules. So if I did x to the 25th divided by x to the 8th, what we said is we subtract those. So you're going to do the 25 minus the 8. You don't have to show that. If you throw a 17 down right away, totally fine. But just so we know where it's coming from, that's what we do. And then we do the same thing with our y's. This has an exponent of 6. This has an exponent of 1. So we're going to subtract those. So that ultimately we would want this to look like 3, and then the x has a power of 17, and then the y has the power of 5. All right. Yes, sir. It is. 1 to the 5th. Okay. So here's how we would have showed this yesterday, and then hopefully I'll actually get to your point that anything divided by itself is a 1. So yesterday we would have talked about how if I have 6 y's in the numerator, because here's what this really means in my numerator, I have 6 of these, right? Y to the 6. Do you agree that means I have 6 y's multiplied? And then I have 1 y in my denominator. Anything divided by itself is a 1. So doesn't this y cancel out one of these, because that's going to turn into a 1? But how many y's do I now have remaining? Yeah, I have 5. So that's why we write that as a y to the 5th. Okay. Okay, number 12. Similar, except does this work out nicely like the previous one? Does 30 go into 36 evenly? No. So we want to reduce that. So if you have your calculators, totally fine. I don't know if I showed you this yesterday. I showed you this in the past for sure. But if you don't like reducing fractions, the calculator will reduce fractions for you. If you just use that fraction key that we've shown you a handful of times. So if you just pull up that fraction bar, if you don't like to reduce fractions, if you're not sure exactly how to do it, or it's a weird, ugly fraction, you could actually just pull the alpha y equals button up. And when you hit enter, it'll reduce it for you. All right. So if you're not good at reducing fractions, if it's an ugly one, if we know how to use our calculator a little bit, we can reduce that down to be a 6 over a 5. So when we do this one, this just right away, 36 divided by 30 reduces to be 6/5. All right, then the x's. So 1, this would give us x to the what power? So when we look at these guys, what do we do with our exponents when we divide like terms? Sure. Fabian, help him out there. What is it? Subtract them. So we would do 11 minus a 5, which is a positive 6. So we get x to the 6. It's always the numerator minus your denominator. So when I go to this next one, when we do our y's, always the numerator exponent minus your denominator exponent. So that has to be 4 minus a 10. So that now is actually going to give you a negative 6. So now this brings into play all the negative exponents. How do we change them to make sure they're going to be a positive exponent? So the way we would write this as a final answer, I'm going to write this as 6 over 5. So we still have the 6 in the numerator, the 5 is in our denominator. Notice how the x is good to go. He has a positive exponent, so he doesn't need to get moved. But since the y ended up with a negative exponent, that would mean that to turn it into a positive exponent, we need to move it. We're going to take it from the numerator, put it into your denominator. And then that's our answer. All right. All right. What we got here? Oh, yeah. Good one here. All right. So now number 13. You could, if you want, we've done this 2 different ways. We could right away do a negative 5 to the 4th power. Same in our denominator. Do 15 to the 4th power. Does anybody know what 15 to the 4th power is? Okay, good. Because I don't know what 15 to the 4th power is. Do we agree it's going to be a really, really big number? Yeah. So if that's the case, probably not the best option to do that right away. All right. So we said also what we could do is simplify inside of your parentheses first. So we're actually going to do that first. That's sort of what order of operations tells us to do anyway. And then we'll deal with the exponent of 4 at the end. So first things first, let's do our numbers. Negative 5 over 15 If you want to rely on your calculator to reduce that, I just showed you how to do it on the calculator. You could do that real quick. This is one hopefully that we could do. If you don't remember, you're just looking for the greatest common factor of these. What goes into both a 5 and a 15? 5. So you can reduce both of those by a 5. So you get a -1 on top, and then you get a 3 in your denominator. Bless you, Riley. All right, and then the x's here. All right, so Sophia back there. What is x to the 11th divided by x to the 3rd? Good. X to the 8th, that's when we subtract them. And then Julia, our y to the 7th divided by our y to the 6th would be y to the what? Good. Y to the 1, because we're 7 minus 6 is a 1. Then we have the inside simplified. Now it's a lot easier to go ahead and raise everything to the 4th power. Do that real quick. So everything now gets raised to the 4th power, and that should end up being our final answer, whatever you get. All right, first things first. I'm going to do the variables first. I think the variables, me walking around, look like we have it down pat okay. X to the 8th to the 4th power should be x to the 32nd. All right, 8 times 4 is 32. And then the y to the 1st to the 4th power, multiply those together, should give us a y to the 4th. Okay? So now, if I did a -1 to the 4th power, anybody brave here? Tell me what that equals. So what's a -1 raised to the power of 4? Marian? What is it? Good. +1. That means I have a -1 4 times. So -1 times a -1 times a -1 is just a +1. All right. Do you know what 3 to the 4th power is, Marian? Good. So if you did this first, 3 to the 4th, 3 gets raised to the power of 4. And then 3 times 3 times 3 times 3 should give us 81. All right. And then that's our answer. All right. Where are we at here? We may... Actually, we'll do one more. Let's finish with 15. And then we'll give you the work here. So we've dealt with some fractions now. Notice how nothing good happens here. So even if we go to our calculator and you're not sure, and I pull up the alpha y equals, and I do a -5 over a 6, and I ask the calculator to reduce it for me, notice how it spits out the exact same thing? That means it doesn't reduce. There's absolutely nothing we can do to reduce that. So that -5, 6 doesn't get changed. So just rewrite that, -5 over a 6. All this one is really doing is making sure we understand the negative exponent idea. So if I then go to my y's, notice how the y has a negative exponent. That means it's in the wrong location of our fraction. So instead of the numerator, I'm going to put that guy into the denominator, and then now the 2 is positive. If I go to my x, do I need to move the x? No, because it has a positive exponent. So we're just going to rewrite that again as x to the 4th. If I go to my z, do I need to move my z? Yes. Currently my z is in my denominator. So in order to make that a positive exponent, I'm just going to put it into my numerator. That's it. That's all you can do. Okay. Okay. I think we're probably going to need to stop there. It's enough. We got most of those done, because I do want to give you some homework on this. But I don't know what I did with this. I might be able to here. Can't be far. It's hidden underneath somewhere. Yeah, you'll do the front and the back. It looks like a lot. The first page takes 5 minutes. Sort of. It's too good to be true there. Perfect time. What's that? It was. It was.
Well, you said front jacket.
Yeah. Oh, correct.